In this lesson, we're going to be factoring ax squared plus bx plus c. Now, in the previous lesson, we looked at polynomials that had a degree of 2, which is a quadratic, and that had 3 terms, which is a trinomial. We're still going to be looking at quadratics and trinomials. The difference is today we're going to be looking at when the leading coefficient is a prime number. So what I mean by the leading coefficient is the number in front of x squared right here. So that a is going to be a number today. In the last lesson, we didn't have a number in front. It was an understood 1. Now, we're looking at a very specific number. We're looking at a prime number, meaning it's going to be numbers like 1, 2, 3, 5, 7. Where there's only factors of 1 in itself. In the next lesson, we'll look at when it's not prime. So before we do anything, let's recall what it means to multiply out binomials. So these two binomials, and we're going to use our little graphic organizer, 2x times x, which gives us 2x squared. Then recall to get the middle term, we use our graphic organizer and do 2x times 3, which is 6x, and 3 times x, which is 3x. And this is going to add up to give me a 9x. And then finally, we multiply our last two terms, 3 times 3, which is going to give me a positive 9. Now, what I want you to realize is that each number in this polynomial, this trinomial, has a linked letter. The x squared has the understood a. The x term, which we also call the linear term, has a b, which is 9. And the last number, the coefficient, is our c. Now, our a, our 2x squared here, this coefficient, came from multiplying these first two numbers together. So that's how we got our a, 2x times x. To get our c, this number right here, we multiplied our last two numbers together. That gave us our c. Now, to get our 9x middle term, our b, this was a combination of our factors of a and c. So what that means is we have to figure out factors of a and c that are going to combine to equal this b, which means we're going to have to do a lot of guessing and checking. And it's just a process. Okay, there's no shortcuts to this. Now, as you get good at it, it will become quicker. But until you're good at it, it's just going to be a constant guessing and checking. So the first thing we have to do is we have to sit down and we have to list our factors of a and c. Because notice these numbers here had really nothing to do with b except for the fact that they added up to be once multiplied out. We really need to know what a and c are going to be. So starting with a, we have 3x squared. So to get 3, we have to multiply 1 times 3. That's going to give me my factors of a. So 1 times 3. That's all we have because it's prime. Then we have to look at our 4 here. Now the factors of 4, they're a little bit more. So our factors of 4 are going to be 1 times 4 and 2 times 2. Now, a couple of things to remember is I always start at the top. I start with 1 and I work my way down until I come to my turnaround. So I started with 1, 1 times 4, 2, 2 times 2. That was my turnaround point. But if it wasn't, I would have went to 3 and then 4 and kept on until I have all my factors listed. Sometimes we get lucky and we only have 1 or 2 pairs. Sometimes we have 6 or 7 pairs. It just depends on the number. Now, notice I've not done anything with my b yet. I'm only looking at my a and my c. So this is a and this is c. So the next thing I'm going to do is I'm going to write down my factor pairs because I know I'm going to need 2 binomials to get this trinomial that I currently have. Now, the good news is I can already tell what's going to go in for 3x squared. I need 1x and 3x, or 3x and 1x. And it doesn't matter the order you pick. So I usually put my bigger number first. If you don't, it's no big deal. So I'm going to do 3x times x, which is going to give me 3x squared. Now, the second thing I look at are my signs. So if we look here, my sign is a subtraction, which means my signs are going to be different. And this is important because that's going to affect what I'm guessing at trying to get this -1 in the middle. So to do this, I know that I have these 2 pairs of factors. I always start with my smallest factors first. Okay, unless a factor is just jumping out at me that I should really try that one, I always start small. So, 2 and 2, to get a negative 4, one of them has to be 2, which means this could be negative 2, and this could be positive 2, or I could reverse it. I could say this is positive 2, and this is negative 2. Now, those are all the possible combinations of 2 because they're the same number. Now, the possibilities for 1 and 4, I could put a negative 1 here and a positive 4 here. Or I could put a positive 1 and a negative 4 here. Then I could switch it. I could say there's a positive 4 here and a negative 1 there. Or I could say a negative 4 and a positive 1. So I have 6 possibilities here that I have to check to see if they're going to work. And it's just a process. I have to do one at a time. So I'm going to start with my negative 2's. If I was to bring this negative 2 right here, and this positive 2 right here, so I'm trying that possibility right there, and I was to check it, that would give me negative 2x and positive 6x. That equals positive 4x. I need negative 1x. So that pair doesn't work. So this is when you need to have a really good eraser on hand. So we're going to erase that. That wasn't a possibility. So now I'm going to try again. If I were to try this next factor pair, the only difference is that my sign would change. I'd have a negative 2x and a negative 6x, which is a negative 4x. So really immediately I could rule out the 2's because they weren't going to work no matter how I tried them. So now we're going to try our factors of negative 1 and positive 4. So if I were to place my negative 1 here and my positive 4 here, I would have negative 1x and positive 12x, which is 11x, and I need a negative 1x. So since this doesn't work, I'm just going to erase, and I'm going to try my next pair of factors. Now again, if I were to try negative 1 and positive 4 here, the only thing that's going to change is my sign. So really when I tried that one, I really ruled out 2 possibilities because it's just changing the sign. So that one doesn't work. That's a positive 11x. So that one's out. So now I'm going to try my positive 4 and my negative 1. So I'm going to put positive 4 here and negative 1 here. So positive 4 times x is positive 4x. 3x times negative 1 is negative 3x. This adds up to a positive 1x, which means I'm really close. The only problem I have are my signs. So instead of erasing everything, I'm simply going to erase my signs here. This needs to be a negative, and this needs to be a positive, which would then give me a negative 4x there, and a positive 3x there, which equals a negative 1. So I have now successfully got my B term. Now, I'm not going to just stop there and assume that I got it right. I'm going to go back and check all my terms. So, did I multiply and get 3x times x to be 3x squared? Yes, I did. Check. I'm going to double check. Maybe I made a mistake. Negative 4 times x is negative 4x. 3 times positive 1 is positive 3. So that's definitely negative 1x. And then lastly, I'm going to do negative 4 times 1, which is negative 4, and that's my third term. So you're guessing and you're checking until you get the right answer. It's kind of like a puzzle. So we're going to put down 3x minus 4 times x plus 1. Or you could say x plus 1 times 3x minus 4. Either answer would be correct because multiplication follows the commutative property. Okay, so now that you've seen the process, you can kind of realize you're going to need either a really good eraser, or you're going to have to write stuff a lot, or you can use a whiteboard and marker if you have that. So let's go down to the next problem, number 1 down here. So all the steps are in this first box. The very first thing you should be doing is checking for your greatest common factor. Okay, the last problem didn't have a greatest common factor, but some of the ones we're going to see will. Then you find your factor pairs for A and C. Remember, A is the first term's coefficient and C is your constant. And then you're going to guess and check until you find a combination that works. Just like a puzzle. Okay, and just like a puzzle, you can sometimes tell certain pieces quickly, like the edges. Well, you can sometimes tell the edges really quickly here, and sometimes you can't. So you'll have to just keep with the process. So let's start with number 1. We're going to have 2x squared plus 7x plus 6. So first thing I look for is a greatest common factor. And when I look at 2, 7, and 6, none of them have a common factor that go into all 3 of them other than 1. So the next thing I'm going to do is I'm going to list all my factors of a, which is my x squared, and my c. So my factors of 2 are 1 times 2. Now factors of 6 are going to be 1 times 6 and 2 times 3. And I know I'm done because I've reached my turnaround point. So now we're going to set up our parentheses. So my parentheses, I have 2 binomials here. Now, I'm particularly liking this problem for a couple of reasons. One, my only factors of 2x squared are 2x and x, but also because my signs are going to be the same. And remember, we look at our second sign first, and then we look to the front. So I know both of my signs are going to be positive. And I like this because that means I'm not going to have to do as much guessing and checking this time. Now, I need to figure out factors that are going to add up to 7. So again, I like to start with 2 and 3. So I'm going to start by putting a 2 here and a 3 here. So when I do that, I end up with 2x. And then 3 times 2 is 6x, which gives me a total of 8x. And that's not going to work because I need 7x. So instead of forgetting these factors altogether, I'm going to flip-flop them. So I'm going to put the 3 first and the 2 second, and I'm going to see if this changes anything. So 3 times x is 3x, 2x times 2 is 4x, and look at that, a positive 3x. Whoa. Sorry about that, guys. A positive 3x and a positive 4x is going to equal 7x. So that means I have my factors. Now I'm going to still double check. 2x times 2x is 2x squared. 3x plus 4x is 7x, so that's checked. And then 3 times 2 is 6. So I have my 3 checks here, which means these are the correct factors. So now I'm just going to write them down. 2x plus 3 times x plus 2. Okay, so let's try number 2. So number 2 is going to be 3x squared minus 8x minus 11. So I'm going to get you started on this one. So of course you should remember that the first thing we need to do is find our factors of a and c. So our factors of a are going to be 1 times 3, and our factors of 11 are 1 times 11. So what I want you to do is I want you to pause the video, and I want you to see if you can figure out where these pieces are going to go in our puzzle. When you're ready, turn the video back on. So the answer to number 2 here is going to be 3x minus 11 times x plus 1. And remember, you can have it the other order as well. You can have x plus 1 times 3x minus 11. So if you got this one correct, I want you to give yourself a smiley face. If you got it incorrect, give yourself a frowny face. And let's try number 3. So number 3 is going to be 3x squared minus 13x minus 10. So this time I want you to try the entire process on your own. So I'm going to give you just a few minutes, and then when you're ready to turn the video back on, turn it back on. So the first thing you should have done was write out your factor pairs for 3 and for 10. Okay, so 1 times 3 and then 1 times 10 and 2 times 5. Hopefully the next thing you looked at was the sign. The sign here on 10 is negative, so they're going to have different signs. So our factors are going to be 3x and x, and then we have to add up to 13 in the middle. So we're going to have a 10 here, and a 1 here. And then we're going to have, well, not quite, right? If we tried this, we would end up with 10x and 3x, which we have different signs, which is going to give us 7x. So hopefully 10 and 1 were not the ones you picked. We're going to need 2 and 5. So I'm going to have a 5 here and a 2 here. And this would have to be a negative, so I could get negative 15x. And this would have to be a positive, so I can get positive 2x. Okay, so sometimes you might think, oh, look, 3 times 10, you know, I have a 3 and I have a 10, that's going to add up to 13, but the signs don't quite work. So this is why you always have to double check. 3x times x is 3x squared. This adds up to negative 13, and 2 times 5 is negative 10. So our final answer here would be 3x plus 2 and x minus 5. Okay, again, if you got this one correct, give yourself a smiley face. If you got it incorrect, give yourself a frowny face. All right, number 4. 2x squared plus 5x minus 18. So again, pause the video. When you think you're ready, turn it back on. All right, so this problem had a lot of guessing on it because we had 3 factor pairs of 18. Okay, but the good news is we only had 1 factor pair for 2x squared. So you should have started by putting 2x and 1x in. Now again, not the best problem because we know we're going to have different signs. So that's going to be a little bit more guessing and checking. So we're trying to get to add up to 5 in the middle. And I know we're going to do plus or minus. So if I try maybe 3 and 6 would be where I started. 2 times 3 and 6, or 2 times 6 and 3. Not quite going to get me there. So 3 and 6 didn't work. However, 9 and 2 do work. Because if I have a positive 9x here and a negative 2 there, I get 9x minus 4x, which adds up to 5x. And then, of course, I'm going to double check. 2x times x is 2x squared. And 9 times negative 2 is negative 18. So this would be the correct answer to this problem. 2x plus 9 times x minus 2, or vice versa. You can have it in the other order, x minus 2 times 2x plus 9. So if you got this one correct, give yourself a smiley face. If you didn't, a frowny face. If you have any questions, make sure you're writing those down as well. Alright, so far we haven't seen a single problem with a greatest common factor. And that's the first thing we were supposed to look for, and we did. It's just that these were all numbers that we could tell immediately there wasn't anything in common. So let's look at number 5. Number 5 is going to be 6x squared plus 10x plus 4. Now, should kind of jump out to you the fact that this has a greatest common factor, because 6 is not prime, especially today where we're only looking at where x squared is prime. That's going to be kind of your clue that that's something you need to look at. However, in the next lesson, you could have a 6 in front. So getting into the habit of always double checking for a greatest common factor is a really good thing to do. Okay, so 6, 10, and 4 can all be divided by 2, which means we can take a 2 out. And that's going to leave us with 3x squared plus 5x plus 2. Now, one of the reasons that we like to take the greatest common factor out first is because it makes factoring what's left over a lot simpler. The second thing to remember is that we are factoring completely. Notice in the directions at the top it says factor completely. This means take out all possible answers, okay, all possible factors. So we've taken out our 2. This 2 is just going to kind of hang around for the long haul. But we need to sit down and we need to factor what's inside our parentheses now. So our A is going to be 3 now instead of 6. And our C is going to be 2. And this is important to realize because some students get confused about this 2 hanging around. He just hangs out until the very end. At the end of the factoring, we're going to bring him down. Okay, he'll be part of our answer, but he doesn't affect what's going on inside this parenthesis. So, factors of 3 are 1 times 3, and factors of 2 are 1 times 2. So I'm really liking this because there's not going to be a whole lot of guessing and checking here. So we're going to put our factor pairs down. So I know it's going to be 3x and x. Another thing I really love about this problem is that the signs are the same. Anytime the signs are the same, it's going to make our life a little bit easier. So they're both going to be positives. Now, we just have to figure out where 1 and 2 are going to fall. So you can either think ahead and think, okay, if I put a 2 here, that's going to give me a 6x, or you can plug it in and multiply it out. So I'm going to put my 2 here and my 1 here, because if I think ahead, that's going to give me 2x, and that's going to give me 3x, which equals 5x. So I know I have my 5x. 3x times x is 3x squared, and 2 times 1 is 2. So now the last thing we have to do is write our whole answer down. So we have to bring the 2 down. 2 goes in the front. Anytime we have a greatest common factor, that number goes first. And then we're going to write these, and they can be in either order. X plus 1 times 3x plus 2, or 3x plus 2 times x plus 1. So it doesn't matter the second two factors what order they fall. It does matter with the greatest common factor. We like to have that in the front because typically it's not surrounded by parentheses. So this would be the factored form of 6x squared plus 10x plus 4. And if you were to re-multiply it out, so if I were to multiply these two, 3x plus 2 and x plus 1, I would get 3x squared plus 5x plus 2, which you saw. And then if I re-multiplied it by 2, I should get 6x squared plus 10x plus 4. Okay? So I want you all to try number 6. So it's going to be 15x squared minus 33x plus 6. So when you're ready, turn on the video. So the first thing you should have done was take out the 3. All three of these terms can be divided by 3, so that's the greatest common factor. Okay, the next thing you should have done is you should have written down your factors of 5, which are 1 times 5, and 2, which are 1 times 2. So now you should have guessed and checked until you figured out where they fit. So the final factors would have been 3 times 5x minus 1 times x minus 2. Because this is the only way you're going to get 11 x's in the middle. Negative x and negative 10x. And again, we like this problem because we knew the signs were both going to be negative because the second sign was a positive, and then you simply look to the front. Okay, both signs are going to be negative. So if you got this one correct, give yourself a smiley face. If you didn't, give yourself a frowny face. And if you have any questions about it, write them down. All right, last one we're going to look at, and this one's particularly important because this is the one people mess up a lot. So negative 3x squared minus 28x plus 20. Now, if you will recall from the previous lesson, the first term, when the polynomial is in standard form, should not be negative. So what that means is we're going to have to come in here and factor out this negative. Now this is where students make a mistake. They don't want to write this step down. If you do not write this step down, you're going to get it wrong. Because if I look at the signs currently, I would think that, oh look, this is a plus, which must mean that both of my signs are going to be the same. But we cannot tell this when the first sign is negative. So what we have to do is we have to factor out the negative, and there aren't any other greatest common factors here other than the negative, and then rewrite the polynomial. So factoring out a negative simply changes all the signs. So this becomes positive 28x, and this becomes negative 20. So notice, instead of the signs being the same, like the original problem said, they're going to be different. And this is why it's so important to write this middle step down. So now the next step is to list our factors of our a and our c. So a is going to be 1 times 3. Now 20 has quite, oops, sorry about that guys, you get to see my puppy. So 20 has a lot more factors. So we have 1 times 20. We have 2 times 10, 3 doesn't go into 20, 4 times 5, and I reach my turnaround point, so I know I'm done. Alright, so we just need to start guessing and checking. So I'm going to bring down the negative, because he's just going to hang around until the end. Now, we know for sure this is 3x and x. We don't know our signs yet, We know they're going to be different. So now we got to look at factors for 4 and 5, 2 and 10, or 1 and 20. The fact that this is 28 means that I'm going to have to kind of look around. Now, again, I like to start with 4 and 5. So if I start by putting a 4 here and a 5 here, so let's say this is a positive and this is a negative, because we don't know what they are yet. Positive 4x and negative 15x do not combine to be positive 28. So I am going to try to switch their spots, because you got to remember this 3 is coming into play here. So if I put the 5 there and the 4 here, that's going to give me positive 5x and negative 12. So that equals negative 7. We need 28. So 4 and 5 doesn't work. So I'm going to mark it out. So going on to our next factor. So we have 2 and 10. So if I put my 2 here and my 10 here, that gives me a positive 2x and a negative 30x. Well, now this is good because that's negative 28x, which means I've got my number. So the only problem I have here are my signs. So if I flip-flop my signs, that's going to give me negative 2x and positive 30, which is a positive 28. So I have my middle term now. Let's double check my a term. So 3x times x is 3x squared, and negative 2 times 10 is negative 20. So I've now found my factor, so I'm going to rewrite it. Negative 3x minus 2 times x plus 10. And again, the only factor here that has to be in the front is the negative sign, or you could put negative 1. The other two could be switched in their order.